In this video, I'm going to do these questions from Chapter 14, Quiz A, which is hopefully going to make sure that you are prepared for our quiz over these types of basic probability formulas. So, in number one, it says 5 multiple choice questions, each with 4 possible answers, appear on your history exam. What is the probability that if you just guess, so just guessing, so the probability of getting a question correct, if you're just guessing and there are 4 possible answer choices, is 1 out of 4 or 0.25, and the probability of getting it wrong or incorrect would be 0.75. Okay? Now there are 5 questions. So if we get none of those questions correct, so none correct, the way I think about doing this is saying the first one's wrong, and the second one, and the third, and the fourth, and the fifth one's wrong. So that's going to be 0.75 to the 5th power. Okay? So you could write 0.75 times 0.75 5 times. That's your choice. But I'm going to do 0.75 to the 5th power. All right, so I get my answer, which is 0.237. Okay, get all of the questions correct. So this would be all correct. So that means I'm going to have 0.25 to the 5th power. All right, so 0.25 to the 5th power is going to be 0.25. The 5th power is 0.00 and looks like 001. So not very likely, which makes sense. You're straight guessing. Okay, this is the type of question where I see the most mistakes with students. It says get at least one of the questions wrong. And if you've been paying attention to the questions that we're doing in class, when I see at least one, I know, or at least anything, I am going to think about finding the complement to this and then subtracting that from 1 to get the actual answer. So at least one wrong would be 1 out of 5 wrong, 2 out of 5, 3 out of 5, 4 out of 5 wrong, or all wrong, right? And so if I want to find the probability of all 5 of these things happening, I'm going to find the complement to this would be none wrong or all correct. So the probability of getting at least one wrong, I'm going to find 1 minus the probability of getting none wrong, which would mean all correct, which we actually just found. So 1 minus this 0.001, which would give me 0.999. Right, so essentially, when I write the answer to this, right, for my answer is like 0.999 is essentially, am I expecting to get one wrong? Yes. Okay, get your first incorrect answer on the 4th question. So this would be, so the first 3 right, so first 3 correct, and then 4th incorrect. So I'm going to do 0.25 cubed times 0.75. All right, because I'm doing the first 3 I get right. So 0.25 cubed and then times 0.75. So 0.012. All right, now that's it for the first one. I'm going to move to this next example, but make sure, come see me if you have any questions about any of this stuff, because this is the kind of stuff you're going to see on the quiz for Chapter 14. Okay, so number 2, we have the company is making peanut butter M&Ms, and they report that 10% of their candies are brown and red. So let's do this to the side here. So this is for brown is 0.1, red is 0.1. Then it says yellow is 20%, so 0.2. Blue and orange as well. All right, so that leaves us, it says the rest of the candies are green. And that's actually the first one we're going to find. It says if you pick one M&M at random, what is the probability that it is green? So in this idea, it would be if you take all of the ones that we have, so 0.1, so brown plus red, plus yellow, plus blue, plus orange. You add those all up and take that away from 1, right? Because the probabilities always have to add to 1. And that will give us the likelihood that it is green. So that's going to be 0.6 plus 0.2, which is 0.8. So 1 minus 0.8 is 0.2. So green is also 0.2. Okay, let's do, it's a primary color, red, yellow, or blue. So the probability of red or yellow or blue. So red is 0.1 plus yellow, which is 0.2, and blue is 0.2. And what you'll notice here is the words that I use were or, and so we're going to be using addition when we have that to get 0.5. So that's kind of the key takeaway from chapter 14, or one of them is when you see the word or, we're talking about addition, and when you see the word and, we're talking about multiplication. All right, not orange. This is an example of a complement. Let me try to get my E's right there. Complement. So not orange, the way you would do this is you write O for orange, and if you put a little C, kind of looks like it's in the power, but a little C up there means it's the complement of orange or not orange. So 1 minus 0.2, right, because that's orange, would give us the complement, which is 0.8. Okay, let's make it a little more challenging by doing 4 M&Ms in a row. So what's the probability that they're all blue? So this is going to be blue and blue and blue and blue. And notice, we've got the word and, all right? And so that's going to tell me that I'm using multiplication. So 0.2 repeated, right? And repeated multiplication, go ahead and just raise that to a power. So 0.2 to the 4th power is 0.0016, or rounded to 0.002. It's not wrong if you put 0016, that's fine. All right, none are green. All right, so this would be not green. So watch this. I'll do the complement. So not green, and not green, and not green, and not green. So the first thing I do is I go to green, which we said was 0.2. So not green is 0.8, and I'm doing 4 of those. So repeated multiplication raised to a power. So 0.8 raised to the 4th power is 0.401. Nope, that's not right. 410. There we go. That makes more sense. Okay. At least 1 is red. Here's that at least again. So at least 1 is red. That's 1 out of 4, 2 out of 4, 3 out of 4. All 4 are red. So to find the probability that at least 1 is red, I'm going to do 1 minus the complement of that, which would be none are red. So it'd be 1 minus, and let's see, none are red. So the complement to red would be 0.9. So 1 minus 0.9 to the 4th power. So let's find 0.9 to the 4th power and subtract that from 1. So 0.344. And that's the most common one that's missed. It's the most challenging. All right, the 4th one is the first one that's brown. So we're going to do not brown. So I'll make this a BR for brown. So not brown, and not brown, and not brown. And the 4th one is the first one that's brown. All right, so not brown, the complement to brown would be 0.9. So 0.9 cubed. So it's 3 not browns in a row. And then finally, we get that brown. So 0.9 cubed times 0.1. So 0.073. Okay, and this last question is a really good way to get some dialogue, some conversation about this idea, one of the main ideas in this chapter. So we have 10 M&Ms that we picked in a row, and we still have yet to pick a red one. A friend says that you should have a better chance of getting a red candy on your next pick. since you've yet to see one. Comment on this statement. Well, really what you're going to hear me talk about in class is it really comes down to how big of a bag your M&Ms are coming from, right? If it's coming from like one of those fun size or snack size, or even just like a king size one, where it's like, anywhere from 10 to maybe 50 M&Ms, whatever it is. Yeah, if you don't see a red one after 10 M&Ms, unless there are no red ones in there, the likelihood of you getting a red one has definitely increased. I don't think you're going to necessarily get on the next one, but you definitely have higher odds now. Your probability has gone up because you haven't gotten any reds. Now, what I talk about in class, I'll say now, is really this comes down to if instead of a bag with a 10, 20, 30, 40, 50 number of M&Ms, imagine your bag has millions of M&Ms, right? So if you've got a bag with millions of M&Ms and you take 10 out that are whatever colors, yeah, your probabilities will change, but they're going to change by such a small amount. It's as if they're not even changing. And this is a concept we'll be using in the next semester to help us make some assumptions before we do some other stuff in stats. But I just wanted to get this concept out there. It really comes down to what's going on in terms of how large of a bag you're talking about. Okay, so I'm not going to write anything, but hopefully you listen to that. We'll talk about it in the class as well, so you can get an idea of how you might answer a question like that if it showed up. All right, so make sure you try the IXL link for chapter 14. Good luck.